source MAC.
What will be
Destination
the
MAC
source
will
MAC
be
address in the ARP?
source MAC will be the who is requesting that MAC address will be there.
Inside the ARP request message.
Then destination will
I
be
think it is
all
destination
zero.
IP and MAC
What will
address.
be the source MAC address in the ARP request message? I'm not talking about Ethernet header. What will be the source MAC address in Ethernet header? My question is, try to understand the question. Source MAC address inside the ARP request,
It's a broadcast message. It's a broadcast message.
not broadcast.
For the
Target
bus
MAC
that
will
you're
be what?
sending it from?
Target MAC will be what inside the ARP request message?
It's a broadcast only.
Broadcast MAC address.
Target MAC will be broadcast MAC address.
Omar, can you mute yourself, please?
Please put yourself on mute, everyone. Yes, now see, there's no any noise. Great. Yes. So target MAC address in the ARP request message is going to be 0.0.0, right? 12 times 0. It means what? It means MAC address is unknown, and target IP address will be the IP address of destination device. But here is one issue. Let's suppose I have one switch. I have one switch here, and few client machines are connected on this switch, PC1, PC2, whose MAC address is A and B. PC1, PC2. MAC address of this PC is A and MAC address of this PC is B, right? IP address is 10.1.1.1 and MAC address is, IP address of PC2 is 10.1.1.2, right? So when I am sending any traffic from PC1 to PC2, right, requirement is source IP, destination IP, source MAC, destination MAC. So one thing is missing, that is destination MAC address. For that, PC1 will generate ARP request message, and we know inside the ARP request message, inside the ARP request message, there will be source MAC, destination MAC, means target MAC, source IP and target IP. So target IP will be the destination IP address 10.1.1.2 and target MAC will be 0, right? It means it is unknown. This will be inside the ARP request message, and after that ARP protocol will hand over it to layer 2 encapsulation protocol, which is your ARPA protocol. Now ARPA protocol is going to add Ethernet header, and inside the Ethernet header again there will be source MAC, destination MAC and type field. Source MAC will be A, destination MAC will be all F. PC will send it to switch will send it to PC2. Great. Within the network, every device can resolve the MAC address of destination IP address, no problem. But here I have another LAN, another local area network which is connected with one router. In between there is one router. R1. I'm saying this is PC3 for an example. PC4 and IP address is, let's say, 20.1 and 20.2. PC3 and PC4. So PC3 can resolve the MAC address of PC4 very easily, no problem. PC1 can resolve the MAC address of PC2, no problem. But can PC1 resolve the MAC address of PC3? Can PC1
By
resolve the
default,
MAC address?
no sir, by default it cannot.
No, sir.
By default not. So what I will do? How it can resolve?
It will send
PC1 can never resolve MAC address of PC3. Never and ever. Why? Can anyone tell me why PC1 cannot resolve MAC address of PC3?
It's a different network. It will have the MAC address as R1 interface.
So if the destination is in different network, then why it cannot resolve the MAC address of destination device? Why destination MAC is going to be the gateway MAC address? Here I am assuming you all know the gateway now, right? Gateway is nothing but the exit point of my network. This is the gateway
Yes.
for LAN 1. This is the gateway for LAN 2. I'm saying this is LAN 1, local area network 1. This is LAN 2. Can PC1 resolve MAC address of PC2? Yes. Can PC1 resolve MAC address of 10.10? Their gateway? Yes. But can PC1 resolve MAC address of 20.1? No. Why? Because we know ARP is an broadcast message. ARP is an broadcast message and router has per port broadcast domain. Means these two ports are in different broadcast domain, correct? So can router forward a broadcast message from 20.10 which is received over here on this interface? Let's suppose router 1 is receiving a broadcast message on F0/0. Can it forward it to F0/1? No, it can't. Why? Because it has per port broadcast domain. Both the interfaces are in different broadcast domain, right? We have already discussed what is broadcast domain, what is collision domain. So router has per port broadcast domain and per port collision domain. So in this case PC1 cannot resolve MAC address of PC3. Then how PC1 and PC3 will communicate? Through gateway. How PC1 and PC2 will communicate? Through gateway. Now understand, if I am going to ping 10.1.1.2, then my PC will generate ARP request message for destination device. My PC will generate ARP request message for destination device. But if I am going to ping 20.1.1.1, my PC is going to generate ARP for gateway, which is 10.10. If gateway IP address is not configured on PC1, it will drop the packet. It can't send traffic to any destination device which belongs to different network. How PC1 will understand that this time I am pinging to different subnet IP and this time I am pinging to same subnet IP? With the help of AND operation.
and operation.
Exactly, right? So it is going to perform AND operation on the destination IP address. PC will find the network ID. Network ID is going to be 20.1.1.0 and my network ID is 10.1.1.0. Both are different. That means destination belongs to different subnet. That means destination belongs to different subnet. And if destination belongs to different subnet, then I will generate ARP request message for gateway. That means destination MAC address will be the MAC address of gateway, not the destination device. MAC address is used to forward traffic within the LAN, within the local area network, right? Not between the IP network. Between IP network, routing is required. Router is going to forward the traffic. We need any layer 3 device. Without layer 3 device, we can't forward traffic from one IP network to another IP network, from one subnet to another subnet, because of ARP. PC cannot resolve MAC address of any device belongs to different subnet. Okay, so remember here, let's suppose here my MAC address is, first of all, here MAC address I am assuming P, here my MAC address is Q, here my MAC address is R, and here my MAC address is C. Okay, so now on the PCs, if you want, these PCs should be able to communicate with any device which belongs to different subnet. Then you have to configure default gateway IP address, right? This is their own IP address. my IP address is 10.1.1.1 and my gateway IP address is 10.1.1.10. Now only PC1 can send traffic to another subnet, because whenever PC1 need to send traffic to another subnet, it is only responsible to send the traffic to gateway at layer 2. Right, at layer 3 destination address will be the PC3 IP address, right? So here source IP will be 10.1.1.1, destination IP will be 20.1.1.1, source MAC will be A and destination MAC will be what, guys?
C.
Destination MAC will be C. Right, if the destination MAC address of default gateway is not present in the ARP table, again it will generate ARP request for default gateway and it will make entry in their ARP table, right? That in their ARP table it will make entry like my gateway IP address is 10.1.1.10, 10.1.1.10 and MAC address is C. Similarly, your PC3 will also have entry in their ARP table that my MAC address, IP address of gateway is 20.1.1.10 and MAC address is R, this way. Now this is your traffic. Source IP 10.1, destination IP 20.1, source MAC A, destination MAC C, destination MAC C. PC will forward it to switch. You know how switch forward traffic. When switch will receive the traffic on their interface, it is going to learn source MAC address. It will make one entry in their table that on my particular this interface a device is connected whose MAC address is A. I have learned it dynamically and then VLAN ID also. After that it will compare destination MAC with their MAC address table and it will find the exit interface. Then finally it will forward traffic to router. Router is going to receive traffic at physical layer, right, into the bits. Then it will convert it into frame and hand over to ARPA protocol. ARPA protocol is going to check destination MAC address. Destination MAC address is C. Yes, this is my receiving interface MAC address. This is my receiving interface MAC address. So what happened? ARPA protocol is going to check type field and it will remove the Ethernet header information and it will hand over the payload, which is packet, to IPv4 protocol at network layer. IPv4 protocol is going to compare destination IP address. Is it the IP address of their receiving interface? 20.1.1.1 is it the IP address of router 1 receiving interface? No. So if this is not the local IP address, then router will simply compare destination IP address with routing table. In the routing table, it will find exit interface for 20.1.1.1 is going to be F0/1. Now router need to rewrite the layer 2 header, right? Because it has already removed Ethernet header and now it is going to forward traffic. So before forwarding, router need to rewrite layer 2 header. So what will be the new source MAC address here? New source MAC address.
Router one's
C
Router
and
exit interface MAC address C and destination MAC.
will be the destination where it's going.
Again, is destination belongs to same network or is it in different network? So yes, destination is in same network. Same network.
Yeah.
Right?
Of course,
The
it's on the
network which is
right
running
hand
on
side.
exit interface and IP address of destination device both belongs to same subnet. So router 1 will generate ARP for PC number 3 and it is going to resolve the MAC address and then it will send the packet. It will encapsulate the frame. After that it will send to switch 2. Switch 2 will again learn MAC address and based on destination MAC address it will forward traffic to PC number 3 and this way PC is going to generate reply. So between the subnet, gateway is required. Without gateway it can't communicate. Between gateway it can't communicate. Here also you have to configure 20.1.1.10. For an example, in my packet tracer, let's suppose these are my clients, all are connected with one switch, right? And somewhere in different room, let's say some servers are there, or at different sites some servers are there connected with switch 2, switch 1. On switch 1 I have lots of clients, on switch 2 I have lots of servers. Right, let's suppose this is my HTTP or web server. Here we can perform the lab of all application layer protocols as well, like HTTP and HTTP on the web server. Here this server can be my DHCP server. This server can be my DNS server. This server can be my FTP server for an example, right? Let's suppose 4 servers are there for now. You can add authentication AAA server as well. And these all servers are connected with another switch. And we need to connect these two different LAN through layer 3 device, because I want to keep servers and client machines in different IP network. Because for servers, definitely you will have different kinds of configuration, different kinds of authentication, different kinds of QS. And for client's machine, you will have different kinds of configuration. So that's why here I am using one layer 3 device like this. Okay, now on PC number 1, for an example, my IP address is 10.1.1.1 and subnet mask is 255.255.255.0. And on this server, web server, my IP address is 20.1.1.1 255.255.255.0. and on the router just I am configuring IP addresses. Today I will talk about basic configuration on iOS device as well. So on the router, let me access it.
So right now, this practical lab that you're doing is it a demonstration of how the OSI model works?
Whatever you can think. Right now I am doing the packet flow.
Okay.
Interface F0/0 no shutdown and IP address 10.1.1. Let's suppose I am using the last IP address from the subnet as gateway 255.255.255.0 and then interface F0/1 no shutdown and IP address 20.1.1.254.255.255.255.0. Then I have configured the IP addresses. So IP interface brief you can see, and so IP route. In the routing table you can see the connected network and local entry. Done. But can PC1 and web server communicate with each other? Can I ping 20.1 from PC1? No, you can't ping. Why?
Not yet.
Gateway.
Ping 20.1.1.1. See, ping is not working. Tell me why ping is not working?
Because the router don't have no route to
No need to
No,
configure
we
any
don't
router
have.
one router.
We don't have gateway.
Yes, we don't have
Because
gateway.
there is no route between the two subnets.
Routing is already there. If L3 device is there, they can perform routing. Gateway is not configured. See, when I said ping
There is no
20.1.1.1,
configuration.
20.1.1.1, what happened? PC1 have generated one message. Which message it is? It is
ICMP.
ICMP request message. But this message is, you can see, incomplete. Nothing is there. So machine PC1 cannot resolve the MAC address of server, and you didn't configure gateway IP address on the PC1. So PC1 cannot send any traffic in different network. But yes, PC1 can definitely talk with PC number
2 and 3 and 4.
Yes, 2 means within the LAN they can communicate. If you want to send traffic to server, here you have to configure gateway IP address 10.1.1.254. And now see, in the simulation, if I am going to ping again, then what will happen? Ping 20.1. Now it has generated one ARP request message. For whom? Not for the destination, not for Windows, so web server. This ARP request message generated for, see the destination IP address,
Okay, 10.1.
Gateway.
Gateway, right?
Yes, sir.
For gateway. Right now your machine don't have MAC address of the gateway. So it has generated the ARP request message, and in the ARP request message you can again check other informations. I can also give you the a screenshot of this message, like how ARP request message looks like.
Sir,
Yes.
I just see before you said it makes, it includes the MAC address like 000, but here it makes FFF. What is the difference?
Let me show you now. Just wait. ARP request. Put yourself on mute, guys, please. Now see here. In the ARP request message, this is ARP request. Here is the ARP request. And this is Ethernet header. Right? So in the Ethernet header, destination MAC address is broadcast. Source MAC address is the MAC address of PC1. And type field is the type code of ARP. And in the ARP request message, you can see the target MAC address is 0.0.0. Target IP address is the gateway IP address. Source IP address is the IP address of PC1. And source MAC is the MAC address of PC1. Okay?
Thank you.
Now, PC1 is going to send this ARP to switch. Switch will broadcast it, and router will generate a reply. Now PC1 have the MAC address of gateway. It can send traffic in different subnet. It can send traffic in different subnet. So now it will send the ICMP packet, and in the ICMP packet, source MAC is the MAC address of PC1. Destination MAC is the gateway MAC address. Right? Means F0/0 interface of R1 MAC address. And IP address will be the destination IP address will be the web server IP address 20.1, source IP 10.1. So at layer 3, source address will be the IP address of PC1, destination address will be the address of destination device, but at layer 2, source MAC will be the MAC address of PC, destination MAC will be the MAC address of gateway. And now it will send the ICMP packet to the router, but router cannot send ICMP traffic to Windows Server because router don't have MAC address of destination device. Here you can run command show IP ARP. So router knows the MAC address of 20.1. No, you can see this entry is incomplete. Right now router don't have MAC address of 20.1. So again ICMP message will goes on hold on router number 1. You can see because of timeout, router has dropped the packet and it has generated the ARP request message. In the ARP request message, again source IP address will be the exit interface IP address 20.1.1.254. Target IP address will be 20.1. Destination device, target MAC address 0.0.0, and source MAC will be the MAC address of exit interface. And in the Ethernet header, type code same, destination address same, source address, exit interface, MAC address. Right? And then it is going to send ARP request message which will broadcast. Only web server will generate reply. And now when your PC1 is going to generate next ICMP message, it will forward directly. You can see first packet got drop here, request timeout, and now you will get a reply message for second ICMP packet. See, 2 packet is dropped because of ARP request message, because router is also solving ARP. 3 packet is dropped. What happened? Something is issue. There is some issue. Is server has the default gateway IP address? No, server don't have default gateway IP address. So what is happening this time? If I will open the simulation mode and show you what is happening, see here, ping. Now PC1 has not generated ARP request message because MAC address is already available, already present in the MAC address table. ARP-A. ARP-A. So you can see MAC address of gateway is here. This is the MAC address of gateway. So PC is not going to generate any ARP request message whenever you will send traffic in different subnet now. ping 20.1. Directly it is generating ICMP packet. Ping is not working. Ping is not working because, let me show you here why ping is not working in the simulation mode. Because on the server, gateway IP address is not configured. Ping, and before that open simulation mode. Through simulation mode, you can check the packet flow. Switch will perform unicast this time because destination MAC is unicast. Router will forward it to server, the same ICMP packet, but server cannot generate reply message. Server is not generating reply message because gateway IP address is not configured. Let me configure the gateway IP address on Windows Server 20.1.1.254. And now if you will check communication between PC1 to Windows Server, then ping will work. Now let me ping 20.1 and you can see ping is working, and this time all communication is unicast only, right? Because ARP table is already updated. Simulation, and again I am going to ping. You can see ICMP request message. It will send to switch, switch will send to router, router will send to switch 2, switch 2 will send to Windows Server, and Windows Server will generate reply. Reply will come on switch 2, switch 2 will send it to router 1, router 1 will send to switch 1, and switch 1 will send to PC 1. This time no one have generated ARP request message because ARP table is already updated on all the devices. On PC1, ARP -A, you can see MAC address of gateway is already there. On router, you will see the MAC address of 20.1 and 10.1 is already updated in the table. You can see 10.1 is using this MAC address, 20.1 is using this MAC address, right? And on the Windows Server also, you can check ARP-A. MAC address of gateway is present in the MAC address table, right? So unicast communication between PC1 to server, which is in different subnet.
Different subnet.
One interesting scenario is there. Let's suppose,
Sir,
yes.
so in unicast, you don't need to configure any route between two different subnets, right?
Routing is already configured. No? Two routes is already there in the routing table of router.
Okay. I think what I'm thinking is that when there are two different subnets, you have to send a static route to the next subnet so that they can communicate.
No, that is not required.
Those are directly connected.
Yes.
Okay, because they are directly connected to the one
Correct.
router, right?
Correct. Here.
Sir, I
Yes,
am sir.
go ahead.
In Ethernet header, the target MAC is 000, right? So which means it is broadcasting.
Sorry?
In the target MAC, it is presented as 000, which means it is broadcasting like that.
It means it is unknown. Broadcast is all F, not 0.
Okay, then why is this represented as 000, sir?
0
Target
means
MAC
unknown.
address?
Unknown.
Oh.
Target IP address is 10.100 or
10.1.
10.254, and the MAC address, target MAC address is unknown. 0.0.0 means unknown, not known. I am looking for the MAC address of target IP address.
Okay, then it will just send to the gateway.
Correct. Here, this side I am using now, not this subnet, I am using another IPv4 subnet. Here my IPv4 subnet is 10.1.1.0/24, and let's suppose this side my subnet is 10.1.2.0/24. Both are same subnet or different subnet?
Different
subnet.
Both are different subnet. Here IP address is, for an example, 10.1.2.1. Here IP address is 10.1.2.2. On PC number 1, you have configured IP 10.1.1.1/24, but by mistaken on PC number 2, someone has configured /8. 10.1.1.2/8. So when I am going to ping 10.1.2.1 from PC1, destination is in different subnet. But when you will ping 10.1.2.1 from PC2, then destination is in same subnet. Yes or no?
Yes, sir.
Then destination is in same subnet.
Same subnet.
So in that case, PC2 will try to resolve MAC address of PC3 directly. MAC address of destination device. How PC2 can resolve then? Then will ping work? Then can I send traffic from PC2 to PC3? In this case,
No, sir.
in this case, can I send traffic from PC2 to PC3? Answer is
No.
No.
no. But if you will test, then you will see ping is working. Why?
Working.
Because of
Proxy ARP.
proxy ARP, right? So by default, proxy ARP is enabled on the interfaces of router. Proxy means sending MAC address of someone else, sending their own MAC address behalf of someone else. So when PC2 will generate ARP request message for target IP address, ARP request for target IP 10.1.2.1, router is going to send their own MAC address behalf of 10.1.2.1 C MAC address, right? So you know what PC2 will think? PC2 will think that MAC address of 10.1.2.1 is C and MAC address of 10.1.1.254 is also C, the duplicate entry. So through proxy ARP they can communicate, and I will talk more about proxy ARP in static routing. Okay, so this is one types of ARP. Again, in topics we will cover, like in different topics we will cover a particular ARP, and at the end you will be knowing all types of ARPs. One is proxy ARP, like gracious ARP, regular ARP. You all know the regular ARP. Done, guys. How packet is going to flow between the network, between the subnet?
Yes, sir.
Yes, right. Now let's come on some application layer protocols. Let's start from DHCP. A very first application layer protocol, DHCP. DHCP stands for,
Sorry, Praphul, quick question. Are you recording today's session?
yes,
Just
today's
wanted to
session is
check.
getting recorded.
Okay.
Then
Dynamic host configuration protocol.
host configuration
Configuration
protocol. You can see even it is clear with their name. Configuring protocol to configure host dynamically. Protocol to configure host dynamically. Used to configure IP addresses to the devices dynamically. Let's suppose you have lots of client machine in your LAN. Right, so at that time when we have multiple PCs and we have like dynamic nature of devices, in that case configuring a static IP address on every device will be time consuming process, and even there is chance of human error. If you are going to configure IP address manually on 500 devices, there is chance of human error. You are not only going to configure IP address, then subnet mask, after that DNS server IP address, then default gateway IP address, right? So this all information is required, right? This is the host configuration. That's why we have DHCP server. DHCP server is another way to configure IP addresses to networking devices. For an example, this is my LAN, again switch. Switch is connected with multiple client machines, and here I want these client machines should be able to get IP address dynamically. So you have to set up a DHCP server. Guys, the primary function of router is routing, but you can use your router as a DHCP server as well, as a HTTP server also, as a DNS server also, right? So either here you can use a dedicated server, Linux server or Windows server, or you can use your router or switch as a DHCP server. If few clients are there, client machines are there, then router can also act as a DHCP server. But if you want a proper DHCP server like a
So
corporate network, then
we're done with the packet flow, right?
this is also packet flow, bro. Why you are in
It's still
hurry?
part of packet.
What you are
No,
trying
I'm
to
just asking.
understand? What you want to understand? Doesn't matter it is
No,
packet flow or DHCP.
no, I'm just trying to follow the syllabus, I'm just trying to be sure that I'm, you know.
In the day one only I had told you, you don't need to follow the syllabus. If you will follow the
Okay.
syllabus, it will be difficult for me, right? Because I am not
Okay.
following any syllabus. I am going in one flow. Okay, so this is, here I have set up the DHCP server, and let's suppose my LAN subnet is 192.168.1.0/24. Out of this, these 254 IP addresses, I am going to assign one IP address to DHCP server statically, that is static IP address 1. Let's suppose 100. And here my switch is connected with one router, and router is using one IP address, let's say last IP address from the subnet 192.168.1.254. So this is my gateway for LAN users. So on the DHCP server, you will create a pool of IP addresses. From that pool, DHCP server will allocate IP address to these client machines. How? See, PC1, PC2 and PC3. Whenever you will click on DHCP, like here also you can see in the packet tracer, if I will talk about the IP configuration, close it, IP configuration. So two options are there, static and DHCP. Even if you will configure, if I will show you the IP configuration on Windows PC, let's suppose on the Ethernet port, properties, IPv4, and you can see two options are there. One, configure IP address statically, and another one is obtain an IP address automatically. So when you will click on obtain IP address dynamically, what will happen? Your machine, client machine, is going to send a request message to DHCP server, and that request message is called discover message. Actually DHCP works on DORA process. You must have heard DORA process. DORA process is nothing but messages of DHCP. DORA process is nothing but, DORA is nothing but the messages of DHCP. D stand for discover,
Discover.
which is the first message of DHCP. O stand for
Offer.
offer, second message of DHCP.
Broadcast.
R stand for
Request.
request, third message of DHCP. And A stand for acknowledgement, right? The last message of DHCP. So what will happen when you will click on obtain IP address automatically? Client machine is going to send a DHCP discover message to DHCP server. How it will send DHCP discover message to the DHCP server? Because this client machine don't have any IP address right now. What will be the source address? What will be the destination address? Tell me. So source, what I told you, if source is unknown, then it is going to be 0.0.0 and destination, as DHCP is unknown for PC1, destination will be broadcast. Right? It will broadcast discover message in the LAN, within the LAN. Two cases are there. One, my DHCP server is within the LAN, or DHCP server is in another LAN, in another subnet. When your DHCP server is in another subnet, then you have to configure DHCP relay agent, because DHCP discover message broadcast and router cannot forward broadcast message. So your gateway will act as a relay agent between DHCP server and client machine, right? Means your gateway will relay the discover message of client to the DHCP server. Relay agent is nothing but you are just configuring the DHCP IP address on router. You will tell to your router that IP address of DHCP server is this one. Then how to send DHCP message to the DHCP server. So again, router will send unicast message. I will come on that setup after this, when my DHCP server is in LAN. Right now my DHCP server is in LAN here. Let's suppose on switch number 1 I have one DHCP server. This DHCP server is using IP 10.1.1. Let's say 10. Default gateway 255.255.255.0 and gateway IP address 10.1.1.254. Go to services and enable DHCP service here. By default this service is off. Let me turn it on, and here you can see what it will do. You can create a pool. By default one pool is exist with name server pool. Here only you can use this pool, or you can create your own pool, new pool. I can create my new pool. Let's suppose LAN with name LAN pool, or with name CCNA. What will be the default gateway IP address for clients? On the client machines, what default gateway you want to configure? 10.1.1.250
Router.
for
Yeah.
DNS server. For an example, let's suppose we don't have DNS server for now. What will be the static IP address? Now tell me the range from where DHCP server should start assigning IP address. I'm saying let's say from 50, 10.1.1.50, 50, 51, 52, 53, or you can say 0 as well, 1, any IP address, then subnet mask, and after that save it. Sorry, save it. Here you can see my pool is saved. Now if this client machine is going to request for IP address, let me open simulation mode and let me try to configure IP on this machine through DHCP. Now you can see PC is generated DHCP discover message, right? In the DHCP discover message you can see at application layer message is generated by client, and client address is 0.0.0.0. At layer 4 you can see source port number is 68 and destination port is 67. DHCP uses 2 port number. DHCP uses 2 port numbers, 67 and 68. 67 is used by
server.
Yes, 67 is used by server. Whenever you will create pool on the even router, automatically 67 port number will enable. Like in GNS 3, if I will take one router, and for now just I am connecting one PC only here. Start port access and see how you can configure DHCP on the router. Interface F0/0 no shutdown. IP address, let's suppose 10.1.1.255.255.255.0 exit. And here I am saying, you know how to check the open port number. So control plane host open port number. By default only 23 port number is enabled, but as soon as I will configure the DHCP pool, IP DHCP pool with name let's say Cisco, and do so control plane host open port number, you can see 67 port number is enabled, right? So now my router is acting as a DHCP server. and 68 is used by 67 used by server and 68 used by
Client.
Client.
client. Right? So in my case here you can see in the layer 4, at layer 4 in the UDP header, DHCP uses UDP protocol at transport layer. So in the UDP header, source port number is 68, destination port is 67. Source IP address is 0.0.0.0 and destination IP address is broadcast. At layer 2, source MAC address is the MAC address of PC1 and destination MAC address is, tell me.
Broadcast MAC.
Broadcast.
So PC will send it to switch, switch will broadcast it. PC 2, 3, 4 is going to drop the packet, even router is going to drop the packet, and server will generate offer message, DHCP offer message. Before that, see, it is generating some other messages here in the packet tracer. This is the issue of packet tracer, ARP request message. For which IP address it is generating ARP? For 10.1.1. Source IP address, destination IP 10.1.1. On the PC number 1, I think a static IP address was configured. No problem, I am not interested to discuss these messages. Here I want to show you the DHCP discover offer message. Let me start again. This machine got the IP address which is 10.1.1.10. In the range I had configured .50, I think, starting IP address.
Yes.
Correct. In the pool, yeah.
In the pool it is 10.1.1.50.
50 to start.
Go to real time, static and DHCP. Actually it is using this pool. Remove it, and in this pool I am going to edit it here, say 50, gateway IP address 10.1.1.254 and DNS server, let's suppose for now 8.8.8 and save it. And now on the PC1, static and DHCP. Now IP address is 10.1.1.50. So you know what happened behind the scene. Actually your PC has sent the request message, discover message. Discover message means I need IP address. Server has sent offer message. Offer message means it is offering the IP address, let's say 10.1.1.50. Some operating system it's offer multiple IP addresses. In packet tracer it will offer one IP address. Then PC is going to send request message. Request message is similar like your gracious ARP to confirm by the server that hey, I am going to assign this IP address. Then finally server is going to acknowledge to PC, and then PC will assign that IP address to the interface. PC will assign that IP address to the interface. Will PC generate gracious ARP here? Will PC generate gracious ARP here? And if you want to see the process in detail, here also you can capture the link. Like for DHCP only, one is you can see in the packet tracer packet, but you have seen in packet tracer after discover message it is generating multiple messages. So in the GNS3 you can see all the messages. On the router I am going to create pool, IP DHCP pool Cisco and network 10.1.1.0 mask 255.255.255.0 default router 10.1.1. What IP address I have configured on the interface of router? 10.1. So let me say 10.1. Okay, and we can exclude this IP address as well. IP DHCP exclude address which you have already configured, right? 10.1.1.1. So it will not assign this IP address. And now on the PC, I am going to say IP DHCP. Once I will hit enter, it will generate discover message, and we have already started the capturing. So we can see all the packets in capturing. You can see DD means discover, ORA, and here in the capturing you can see all the packet. Just look at all the packet, guys. Source IP, destination IP. See right side, here is the name of packet, discover. Client machine has sent 2 discover message. First discover message got dropped, so again it has sent the discover, then server has sent the offer message, then request message, and then acknowledgement message. All the message except acknowledgement message is broadcast, not broadcast. Offer message is also not broadcast. But at layer 3, can I show you at layer 2? At layer 2 you can see one discover message. See, source IP and destination IP, source MAC and destination MAC. Discover message is broadcast at both layer, at layer 2 as well as at layer 3. See the offer message. Source MAC and destination MAC both are private, because see, DHCP server can learn the MAC address of client machine through discover message. In the discover message, client machine is sending source MAC address, right? In the discover message, source MAC address is there, MAC address of PC1. So your router is going to learn it. Router is going to learn it. It will even update the ARP table. So IP ARP, MAC address of 10.1 is this one, MAC address of 10.2 is this one. 10.1 is their own IP address, their own MAC address. This is the IP address of PC. So DHCP server knows the MAC address of DHCP client. That's why offer message is unicast at layer 2. But at layer 3, this message will be broadcast in Windows operating system. 1 minute, please. In Windows, all the message is going to be broadcast at layer 2 as well as at layer 3. In Cisco operating system, discover message is broadcast, offer message is
unicast.
Request message is broadcast, client machine is sending, broadcast message only. And again acknowledgement message is unicast. In the Windows operating system, here in packet tracer, if I will try to show you the packet once again, let's suppose from PC number 4, I'm going to say DHCP. So see the discover message, source 0, destination broadcast. At layer 2, source MAC is the MAC address of PC, destination MAC broadcast. It will send to switch will forward it to all the devices. Server is going to generate offer message. It is not generating offer message directly here in the packet tracer. No, in packet tracer it is not giving me the correct output. You can try with connecting server and PC only, right? You can connect PC and server directly, and then you can check if server is generating the offer message directly. And if you will check, all the message will be broadcast. Or if you have the EVNG setup or you have VMware, you can configure DHCP on Windows server as well, like in the Active Directory. I am expecting you all know the DHCP configuration. If I will access my Windows server, password is, here is my domain controller network, right? So in Windows server, how we configure DHCP? Here is the DHCP, and by clicking on your domain, then IP, you can create a scope, new scope, and here you can next, you can define the name of your scope, let's say Cisco, next, and here starting IP address, end IP address, subnet mask, and then in next step it is going to ask you DNS server IP address and gateway IP address, right? So we can use our router as a DHCP server, we can use a dedicated DHCP server, both will work fine. Difference is, on Cisco operating system all the messages are not going to be broadcast. On Windows operating system all the messages is going to be broadcast at layer 3. At layer 2,
Sir, is it possible to have a different DHCP server on Windows?
yes, you can have different like
Different
DHCP.
subnets, configuring the different
Yes,
subnets as a
of course,
DHCP server.
of course. Here I am going to show you even that as well.
Yeah, I think you should have completed the when you log into your Active Directory Windows, you should have completed the configuration so that we can see.
See, we don't need to understand the DHCP configuration on Windows server. We need to understand DHCP on router, Cisco router. What I am saying,
Okay,
the behavior is quite different there. If you want to test,
okay,
you
no,
can test it. Here,
no
our
problem.
another thing in DHCP is, what if DHCP server is in different subnet? So I am going to show you that scenario as well. For now, this is basic of DHCP. The DHCP stands for Dynamic Host Configuration Protocol. It is an application layer protocol which uses UDP protocol and transport layer and two port number 67 and 68. 67 is used by server, 68 is used by client, and DHCP works on DORA process. Clear?
Sir, in case of DHCP also gracious ARP will be sent, no?
Who will send the gracious ARP?
No, just asking, sir, whether it will be done or
Done
not.
by whom? By server or client?
Client.
Client.
No, not required. In case of DHCP, PCs clients are not going to generate gaseous ARP. It has already generated the request message. What I told you, request message is kind of gracious ARP, right? So here PC is not going to check duplicate IP address by themselves. DHCP server will ensure that the IP address is not duplicate. This
So,
is
but
our,
in packet tracer, there is some gaseous ARP generated.
that is the error.
Whenever.
That's why I have
Okay.
not shown you na here.
Okay.
Server is generating, where PC is generating gracious ARP. See,
No.
let me try to check again.
In GNS3, it was showing something which you captured, no, sir. In that, it was showing gracious ARP something.
See here, server is not generating reply message. It is ICMP. ARP. Source port number 6. This is the packet which is came here. No, it is sending another message here. In the capturing,
There it was showing something.
okay, I have
GR.
read the capturing. Again, I will capture. Don't worry. We'll see. Now, from here, I am going to delete this server because for the server, I have a dedicated server room. So now let's suppose this is my DHCP server, and this side here I am using one subnet 192.168.1.0/24, and this side my LAN subnet is 10.1.1.0/24. Let's suppose IP address of this web server is .1, IP address of DHCP server is .2, IP address of DNS server is .3, IP address of FTP server is .4. On the server, you will always configure a static IP address. Can anyone give me the reason behind it? Why I should configure a static IP address on the server?
So you don't lose the services from that server. If it's DHCP, you need to know where the DHCP server is located. If it's a web server, you need to know where that web server is located. If it's dynamic, it keeps changing, then you will have those issues that you won't be fine. You won't be able to resolve or get to the destination.
Exactly. So when DHCP server is offering the IP address, that IP will be keep changing, right? IP address will be keep changing, but my servers are a static device, right? This server will be always web server only. That's why here we will configure a static IP addresses. Let me configure the IP addresses quickly on these all servers. 20 dot not 20 192.168.1.1 subnet mask default gateway 192.168.1 dot, let's suppose 100, and DNS server IP address 192.168.1.3, right? Close it, go to DHCP server desktop, IP config 192.168.1.2, gateway 192.168.1.100 and DNS 192.168.1.3. Go to DNS server 192.168.1.3, 192.168.1.100 and 192.168.1.3. FTP 192.168.1.4, 192.168.1.1 and 192.168.1.100.
No, DNS is 3 and default gateway is 100.
Default gateway is 100 and DNS server IP address is 3. Great. Okay, done. I have configured the IP addresses. Now I want these client machines should be able to get IP address from DHCP server. So on this DHCP server, I am going to create one pool. Go to DHCP, enable the DHCP service, right? For the pool is by default available. Here I am changing the gateway IP address, or I can create my own pool with name, let's say Cisco. Gateway IP address will be what? Here I am going to configure 10.1.100 and here it is 1 dot again 100. This is my IP addresses on router interfaces. Okay, so on the DHCP server, gateway IP address will be 192.168 dot not 192 10.1.1.100. It is in different subnet, right? This default gateway is in different subnet. DNS server 192.168.1.3, static IP address 10.1.1.0, or let's suppose from the 10, right, and just save it. Here is my pool. You can see this pool with name Cisco. For which LAN? For LAN 1. But if this PC will try to get IP address, if this PC will try to get IP address, you can see it can't get IP. And if DHCP server is not offering the IP address, then your device will get a temporary IP address for temporary communication, so that it can send the traffic. That is a pipa. So right now it is getting IP from, you can see, different range 169. This is a pipa range, right? You can see DHCP fail, a pipa being used. DHCP server fail, a pipa being used. Why? Let me open the simulation and let me show you what is happening. On the PC, if I am going to say DHCP, see my discover message, right? Same discover message, source 0, destination broadcast. At layer 2 also source address PC1 MAC address, destination broadcast, and source port destination port 68 and 67. It will send to switch will broadcast it, and all the devices are going to drop it. Router 1 cannot forward it to DHCP server. It is broadcast message. Here you have to configure relay as a agent, right? You have to tell to your router that, bro, R1, DHCP server IP address is 192.168.1.2. Whenever you will receive a DHCP discover message, I know that is broadcast. You can't forward it. But do one thing. Just convert that message into unicast, send to DHCP server, like talk to DHCP server with unicast message and then reply to client machine. You will act as a relay agent between DHCP client and DHCP server. So, yes, go ahead.
That's also called a helper address, right?
Yes.
Okay.
Okay, so on the interface F0/0, where router will receive the discover message on this interface, you will run one command, IP helper address, and the IP address of DHCP 192.168.1.2. But this IP address should be reachable from router. Doesn't matter where it is. Maybe it is in different building, different floor, or different sites. Maybe clients are in branch 1 in India and server DHCP server is in US in the data center. Your gateway should be reachable from the DHCP server. This IP address should be reachable. So server is already reachable. Ping 192.168.1.2. I can ping to DHCP server. Why ping is not working? Config T, do show IP interface brief. You can see IP address on interface is incorrect. So interface F0/1 IP address 192.168.1.100 255.255.255.0, and on interface F0/0 my IP address will be 10.1.1.100 255.255.255.0. That's it. Now if you will ping again, then you can see ping is working, DHCP server is reachable. Now what will happen if client will request for IP address? Let me open the simulation mode and let me show you. Here you just discover message, right? And you are familiar with all the fields in the DHCP discover message. See, like this you can take a snapshot of ARP request, ARP reply. You can try to read the output. It will send to switch will broadcast it, but this time router is going to send one unicast message to DHCP server. If I will open this message, then you can see this message. Outgoing packet which is going, outbound packet. See, source IP address is what? IP address of my router interface 10.1.1.100, which is the gateway for PCs. Destination IP address is the IP address of DHCP server. This is unicast message. Source MAC address is the MAC address of router F0/0 interface IP. Sorry, I am saying IP, MAC. So interface F0/0, F0/1 include BIA. See, is it the same MAC address? Source MAC address? In last 9C02, source MAC. Zero C, right? Exit interface MAC address, destination MAC address is the MAC address of server, DHCP server. Here you can see the destination MAC in last E5, right? So router has converted broadcast message into unicast, and then it is sending to DHCP server, and DHCP server will generate offer message for whom? For your router, right? Because DHCP server is thinking that your router is generating DHCP discover message, and again your router will convert unicast message into broadcast, and then it will send to this LAN network. It is sending another message, ICMP or ARP message, don't know what is happening here. Okay, let me tell you here what is happening and how it will work. Client machine will generate discover message, which is broadcast. It will send to router to gateway. Gateway is going to convert broadcast into unicast, and it will send to DHCP server. Server will generate again offer message. It will send to router. Router will send to client machine. Client machine will send request message and to the router. Again router will convert that request message from broadcast to unicast, and it will send to server, and then finally server is going to give acknowledgement, and then client machine will assign the IP address. Now I am assuming client machine have the IP address, default gateway, DNS server IP address. Here you can see 10.1.1.10 is IP address, submit mask 255.255.255.0, gateway IP address 10.100, and DNS server IP address 192.168.1.3. Let me check on PC number 2. Go to PC 2 and click on DHCP, and you can see PC 2 got the IP address 10.1.1.11, default gateway DNS server IP address. It is correct. PC 3 can also get IP address, static, dynamic, .12, PC 4, all the machines got the IP addresses. This is our first application layer protocol, DHCP. Now here you can see I have FTP server, right? Guys, can anyone tell me about FTP protocol? What is FTP protocol and why we are using it?
Just a file transfer protocol to send and
FTP
receive
file
files.
transfer protocol, right? To send,
Receive files.
In a reliable way.
Okay, in a reliable way. File transfer protocol. Uses which protocol at transport layer?
You mean port number?
TCP or UDP?
BTCP.
TCP.
TCP.
Port 21.
TCP.
Port 21.
TCP port
21.
21. So let's suppose now I have some file on PC number 1. You can create file 1 on the PC 1. Let me do one thing here. See, some softwares are there to create file. Yes, text editor is there. Let's suppose here I am creating a file, text file. Hello everyone, welcome to PM networking, right? And just save it with name, let's suppose pmnet.txt. So I have saved this file. I have created this file. Save it. You can check in directory as well, dir. You can see in the directory file is there, pmnet.txt. I want to share this file. I want to upload this file on this FTP server so that everyone can access it. How you can do that? You can configure FTP server first here. IP address is already configured. Go to services and then search for FTP somewhere. FTP. By default, this service is already enabled and one user is also there with name Cisco, password Cisco. This user has write access, read access, delete access, rename access, right? And you can create more user as well. For an example, admin, and password admin@123. Add it. I can get one more user, Praphul, password Praphul@123, and add. What happened?
You haven't selected permissions.
Add. Right now, let's suppose this is my PC or this is admin PC. So how admin will access this FTP server? Through command prompt they can access FTP and the IP address of FTP server 192.168.1.4, and on the FTP server you will see some files are available, the default files FTP. You can see these files, but we don't have pmnet.txt file. Pmnet.txt file is on PC1, right? So from PC1 I want to upload it on FTP server. First of all, I am going to access FTP server. It is asking for username. Username is, let's say, admin. Password is admin@123. I got the access to FTP server. To upload something, there is command put command put, and file name pmnet.txt. Enter. Now you can see 40 bytes copied. On the FTP server, if you will check the directory now, then somewhere you will find pmnet.file, pmnet.txt file. Yes, here you can see. Now anyone can download it, right? Let's suppose this is Praphul PC, PC2. Praphul want to download it. So again I will open my terminal. I will access FTP server, FTP 192.168.1.3. username, my username is Praphul. My password is Praphul. Don't have permission.
3 is
It's
DNS.
not. It's that far now.
Oh, it has to be 4.
4. Username Praphul. Password is Praphul@123. I got the access to FTP server and I want to download some file. So get command is there, get, and file name pmnet.txt, and you can see 40 byte data is copied, right? If I will exit from here and if I will show you my local directory, Control C dir, you can see in my local directory one file is there, pmnet.txt, right? So this is again one application layer protocol, and if you want to see the message, you can open simulation mode, click on any PC. Let's suppose PC3. For packet flow, close it, PC3, and FTP 192.168.1.4. Enter. You can see 2 messages. Why 2 messages? One is TCP, one is ARP. ARP for whom? See the target IP address? For gateway, right? So PC3 don't have MAC address of gateway, right, in the ARP table. That's why it has generated the ARP request message. First it will resolve the ARP of the gateway, and now it will send FTP message. But FTP is a TCP protocol. What I told you, before sending actual data, TCP protocol will establish control connection,
Three-way handshake,
right?
control
Three-way
connection.
handshake. It
Yeah.
will perform 3-way handshake. So it is sending SYN message. This is what? This is SYN message. Here you can see. In the TCP header, see source port number, random port number, destination port number, well-known port number of FTP, well-known port number of FTP, sequence number 0, acknowledgement number, window size. You can see yesterday I had talked about window size, right? Flags, here we cannot open the flags, but for that you can
001. Here
yes,
we have
00. You can
last
also capture
01.
link in Wireshark. Here you can see the flag. right? 0B, after that some 0, then 0 1. Actually SYN bit is on in this flag bit. It will send to server. Server will send SYN plus ACK. Server will send SYN plus ACK message. Source port number, well-known port number, destination port number, the random port number used by switch, source address, destination address, right? This will be definitely unicast message. Switch will send it to PC. Now PC is going to send acknowledgement message, and after the acknowledgement PC will send this is TCP ACK message. Here you can see FTP request message. Actually server is going to authenticate user. It will ask for username and password. Same informations are there. Flag bits is different this time. Sequence number, source port number, destination port number, right? Window size same, IP header and Ethernet header, right? Now I am expecting these all informations. It will ask for username, password to the server. Server will share the credential. It will ask to you. So on the PC you can see it is asking for username. If I am going to say admin and password, now it will ask me for password. In simulation mode it will take some time. It is authenticating one by one, I think. Username, and now it will ask me for password. When it will receive this message, then it is going to ask you for password. Now you can see first it has authenticated the username. Now it is authenticating the password. Password was admin 123, and now it will send the password to the FTP server, and server is going to give the final access. Right here now you will have access to FTP server on this PC. You can see, right? So doesn't matter which protocol is, it is for all the protocol packet flow is going to be same for FTP. Now let's take example of HTTP protocol web server. Here I have web server. Tell me about HTTP protocol. HTTP protocol uses which service or transport layer? TCP or UDP?
TCP.
Port number?
443 or 80.
HTTP 80,
Only 80.
HTTPS 443. Yeah.
Yes, HTTP 80. And used to access
80 and
Web pages.
web
web.
pages. Now on the server I am going to configure, I am going to enable HTTP service. HTTP, this service is on, and yesterday I had shown you the HTML coding as well. Right, save it, and now in the browser of any PC, if you are going to type this IP address, browser, web browser, and if I am going to type the IP address of web server, again three-way handshake will happen first, and after that my PC is going to send HTTP request message, and then I will have reply message, and finally I will get the web page 192.168.1.1. You can see I got the web page, and if you want to see the traffic, open simulation mode, go to any other PC, in simulation it takes some time, so type the IP 10.1.1. not 10, sorry, 192.168.1.1, and then click on simulation mode, and after that hit enter. Again packet is going to flow in same way. You can see TCP SYN message, source port number, random port number, destination port number, well known port number of HTTP 80, source IP, destination IP, both are unique. Source MAC, MAC address of PC3, destination MAC, MAC address of default gateway, right? So three-way handshake will happen for all TCP based protocol. SYN plus ACK message, and then finally server is going to send ACK message acknowledgement. At the same time it is also sending HTTP request message, right, after acknowledgement message. And in the HTTP request message also you will have same information. You can see source port, destination port, source IP, destination IP, source MAC, destination MAC. It is going to be exactly same, right? So just I don't want you guys to look at this information now. I want you to perform this lab and then check this information like verify port, IP and MAC. Also check the MAC address of devices that it is same or not. Now you can
Yes,
see.
sir. Yes, sir.
Hmm.
I saw you configure the web server. What about in a situation where the web server is accessed by an outsider? Like they have to
Outsider?
enter a domain name. Yeah, they have to enter a domain name to access the web server.
Okay, I am
How can
coming
that
on
be?
that also. You guys are one
Yeah,
step
like
away
someone
from.
have to enter like www.google.com
Okay, okay,
to
got it.
access the Google web server.
Okay, okay. So see, I got the web page of Windows Server, right? This is also one application layer protocol. You can understand the packet flow. Now here I have another application layer protocol which is DNS. So who will tell me about DNS? What is DNS?
Domain name resolution system.
Domain name server. Use
Domain name
domain name
server, yeah.
service.
Yeah,
Service. Yeah.
domain name
You
server.
can say domain
Used
name
to used to
server
re, yeah
or
used to resolve IP address to names to IP address.
system, right? Used to
Is
Resolve I name
resolve
to
IP
IP address.
to a domain name.
domain name
Name.
into IP address, right?
Address.
IP
Because we
address.
know remembering the domain name is easy than remembering the number. Remembering the number is difficult. How many of you have remember my mobile number? No one. But almost all of you know the name. My name is Praphul, right?
Praphul.
So remembering name is easy. We can't remember the IP address of each and every website, but we know the google.com, facebook.com. So DNS resolve domain name into IP address. You can browse www.google.com. For an example, this is PMNet website. On the Windows server, this is PMNet website. So people will browse pmnet.com and DNS server will resolve the name into IP address, right? So on the DNS server, you will create the database. You will create the database. Database means domain name and IP address. www.pmnet.com is a domain name whose IP address is 192.168.1.1. www.google.com is a domain name whose IP address is 100.1.1.1, like this. This is what DNS database on the DNS server, right? And let's suppose client machine is here. This client machine is browsing this domain name. If you will browse this domain name www.pmnet.com, pmnet.com. First of all, your machine is going to check the DNS server IP address, that DNS server IP address is configured or not. If DNS server IP address is not configured, it cannot resolve this domain name. If DNS server IP address is already configured, let's say DNS server IP address is 10.1.1 and my PC IP address is 20.1.1, and PC also know the DNS server IP address 10.1.1.1. So in this case, if you will browse this domain name, what will happen? Your DNS server is going to generate one DNS request message, which is DNS query. DNS uses which protocol at transport layer?
UDP.
UDP. And port number?
53.
53.
UDP port number 53. So DNS is going to generate a DNS query message, or you can say DNS request message. DNS request. This request message will request for IP address of www.pmnet.com. Source port will be what? This will be the information in DNS request message. Then layer 4 header will be there. Source port number, random port number, destination port number 53, source IP 20.1, destination IP, DNS server IP address, source MAC address of PC, destination MAC. DNS server is in same network or different network? It is in different network. So gateway MAC address, right? And then server is going to generate DNS response message, reply message. In the reply message, it will see here IP address, right? www.pmnet.com. domain name and IP address is, let's suppose, 192.168.1.1, right? Again, TCP header source port 53, destination port 1025, source IP 10.1, destination IP 20.1, source MAC, DNS and destination MAC gateway. This is my DNS reply message. Let's set up it over here in packet tracer. DNS, close it, go to services and look for DNS service. Here it is. Let me turn it on. By default DNS is off. On here you can define the domain name www.pmnet.com and the IP address of pmnet.com is 192.168.1.1 and add. Like this you can create multiple entry www.google.com and IP address 192.168.1.1, right? Fully qualified domain name. You can define the full domain. Now if I am going to browse www.google.com in the browser on PC number 3, note the IP address, what will happen? My machine is first going to generate DNS query message, and for that DNS IP address must be configured on PC. PC should have the DNS server IP address. So tell me guys, do PC know DNS server IP address? Does PC know the DNS server IP address?
Normally, yes.
Yes, here we have configure, right? PCs are got IP through DHCP, and DHCP already given the DNS server IP address. You can see 192.168.1.3, right? So all PCs knows about DNS server. Let me hit enter here, and before that let me use simulation mode. www.pmnet.com, enter. See the DNS query message or DNS request message. If you will open this DNS request message, open it, check outgoing packet. See Ethernet header. In the Ethernet header, source MAC address is the MAC address of PC, destination MAC address is the MAC address of gateway, type code is IPv4 packet, upper layer protocol is IP, source IP address IP address of PC, destination IP address of DNS server. In the UDP header, source port, random port number, destination port, well-known port number of DNS, and here you can see the DNS header, right? It is asking for this domain name IP address. That what is the IP address of this domain name, www.pmnet.com. PC will send it to switch, switch will send to router, router will send it to DNS server, DNS server will check this entry in their database. If this domain name is available in their database, then it will generate DNS response message. This is another message. It is just resolving the MAC address of gateway. And now here you can see the DNS response message. If I will open this DNS response message, and if I will show you the data, then you can see in the Ethernet header we have similar information, IP header, UDP header, and here is the DNS query. In the query it has someone has query for this domain name, and here in the answer you can see the domain name this one, and IP address is 192.160.1.1, right? When your client machine will receive this DNS response message, it is going to generate SYN message, TCP SYN message. Like now from here the process is going to be same like you browse IP address in the browser, right? TCP message, it will send SYN message, server will send SYN plus ACK message, client machine will send HTTPS request message, and once reply will come, you will have web page. See, right? So like this, I had told you to learn these protocols at application layer.
Sir, I have a question.
Go ahead, go ahead.
If the DNS is sitting on another network address, let's say 192.168.2, do we need another IP helper, or?
DNS is in another subnet only, bro. Client is here and
If
DNS is here.
That is also my question I wanted to ask. Like for example, for us in
question.
Okay.
Wait, Idris. If it sits on another subnet, I mean, if it sits on 192.168.2.0/24, do we need another IP helper on the router?
No, why it is required? DNS message is unicast. Helper and nothing is required for DNS. Doesn't matter where it is. DNS server may be in the different subnet in different site, but your client machine should have the reachability to the DNS server. That's it.
So my questions are, like for example, we have a DNS that is hosted on the Bluehost, and we have an application server locally, and we wanted to connect the DNS to that application server that we have locally. How is that possible for clients to?
Like this only, na? That is also same scenario. What is different there?
Let us assume that the application server is using a private IP address and the DNS is using public IP address.
Okay.
So how can we synchronize all of this to?
What you will synchronize?
And
I have not synchronized anything.
is inside our network.
Guys, let's suppose this router is connected to internet.
Yeah.
and on the internet I have one server with IP 100.1.1.1. So on the client machine I will say DNS server IP address is 100.1.1.100, or on the DHCP server I will configure DNS server IP address this one. So client machine will get this IP address as a DNS server. So whenever you will browse the domain name, it is going to send DNS request message to DNS server. This is the same scenario which we have discussed here, or maybe this is on the AWS, doesn't matter. This is VM, right? We only need the DNS server IP address. This is the same scenario, brother.
I'm not. I seem not to be to be understanding. But anyway, let's move.
What you are not understanding? I'm saying this router is
Let me
connected
say,
to
for
internet.
example.
Where is your server?
Now,
Tell
for
me.
example,
Application server, where
let
it
me
is?
give you an example.
Tell me where is
Let
your
me give you an
DNS
example.
server?
Let me give you an example. Presently, we have our application server.
Okay, let's say this is the
seated
application server.
seated on our local network.
Okay, let's say this is in local network application server.
Exactly. Then we have our website. We hosted it on Bluehost.
Okay.
And we created a subdomain on that server.
Okay.
So we want that subdomain to connect it to this application server, so that the clients from the outside can access that server directly using the domain name.
Okay. So client should have DNS server IP address.
I think I
Not the
understood your
entire client.
I think I
Not
understood
the
your
entire
question.
client. I'm talking about the
You-
outside clients outside that are
you
using.
you're talking about your web page hosted on your website hosted on outside network on the internet. You will
Yeah.
that is a completely different question to the concept what Praful is explaining. Whenever you have a website hosted, you will have, like, within DNS you have a record which is published in a public domain name system. Using it will maintain a MX record history. That subdomain will be advertised on the internet. That's a completely different concept compared to what this class. So you are trying to access a web page hosted on an internet through your local network. If that's or your application server wants to know how to get that page, and you want to get that page available to your LAN network. Is that what you're trying to do?
No. I have the application server is seated on my local network.
Yeah.
And I create a subdomain on my website.
Yeah.
Which is hosted on Bluehost. So I
Okay.
want that subdomain to connect it to the application server on the LAN network, so that clients from outside can access my local web page, my local website application.
Your subdomain needs to be connected to your local application server. That's your query.
Exactly.
Yeah.
That is what I'm asking.
Yeah, because even whenever you register a subdomain, it is more so you gotta get that validated. There are MX records on the internet which will validate your subdomain, so the outside world knows where that subdomain resides, and your subdomain will have a IP address. So to the outside world, your subdomain will have your subdomain name, which is linked to an IP address, which is again within your network. So you got to put that associate that IP address, and then again, once it hits your network, that IP gets to route to wherever you want to route it to the app server. So that is again a niche DNS systems engineers who mostly work on that sort of concept. It could be explained more so within the in-depth DNS related stuff within
Yeah.
system engineering. That I think what's covered here is slightly different. Um, what Praful is covering here is related to where your domain name, where your DNS server local is. Again, the DNS server, it maintains the very definition of the DNS service is maintains domain names to IP addresses. As long as
Exactly.
as long as your subdomain is defined within your DNS server locally, that okay, this domain name xyz.com is located at this IP address, your network knows how to get there.
So my question is, if my web server is in my local network with a private IP and the subdomain have a public IP, so how can I associate all of these two network so that the outside world can easily enter my domain name and access the web server which I hosted internally? Is it possible? That's my question.
Of course, if your website is already have the public IP, then the public domain name systems have already propagated that information, so everyone know to get there.
Anyway, let's
Maybe
move on.
internally, like you can use an adding, right? You can convert public to private.
Yeah, but he already has his web page or hosted on a public
So,
IP.
are you using a load balancer?
Not at all.
No, that's
So guys, see,
In,
wait. See, these are the application layer protocols which we have covered. Now you also need to perform lab of it. Some more protocols are there, like NTP you can see, used to keep the device synchronized with time server, right? Again, you can have your local time server or you can use the public time server. For DNS also, we have total 13 public root DNS. That server is called root DNS server, like when we are purchasing domain, like someone said from the Bluehost, right? So ISP is going to resolve that. Who will resolve that domain? ISP is going to resolve that through root DNS server. So on your machine, you can configure two types of DNS server IP address. Local DNS means primary DNS and secondary DNS. Let's suppose if I have say I browse pmnet.com, my machine is going to request to DNS server that tell me the IP address of pmnet.com. Let's suppose if DNS server will not find any entry, then DNS server is going to forward the request to root DNS server, the secondary DNS server, only if you have configured the DNS server IP address on your DNS server. DNS uses TCP as well as UDP protocol, both protocol, not only UDP. Here you can see uses both TCP and UDP. When it uses TCP, when it uses UDP, so whatever we have learned here, that is UDP based. That is UDP based. Now imagine that this is my company network. Switch PC, and here is my DNS server. This machine is using IP 10.1, 10.10. Here I have browsed www.pmnet.com. What will happen? This machine is going to generate DNS request message for the DNS server. DNS server is going to compare domain name with their database. If this DNS server will not find entry and DNS server IP address is configured over here, then it is going to ask to another DNS server. Let's suppose one more DNS server is available in my DC. Here is my DC data center, and in this data center again I have one DNS server, and this DNS server IP address is, let's say, 20.10. So here I say DNS server IP address 20.10. So what will happen? This DNS server is going to ask to this DNS server, and this is going to be TCP based, right? So DNS server is going to communicate with another DNS server through TCP protocol, and client is going to communicate with DNS server with UDP protocol, right? And even if you want that this DNS server which is located in your DC should have the information of root DNS server, which is the public DNS server available on internet. Total 13 or 14 root DNS server is available. Here also I can configure DNS server IP 8.8.8.8. So whenever this DNS server is going to receive any DNS query message request, it will compare domain name with their local database. If it will not find the entry, then it is going to ask to 8.8.8.8 to the public DNS server, and again it will be TCP based. One reply will come from this DC DNS server to this DNS server. First it is going to update their on data base, right? So DNS entry can be created statically or dynamically. Here it will learn the IP address of a domain name pmnet.com dynamically, and in the packet tracer I have shown you how you can create a static entry. After updating their local database, it will send the IP address to client machine. So DNS is not only using UDP protocol, it is UDP and TCP based protocol. This is one more thing about DNS. After that, NTP protocol uses port number 123 and used to synchronize the time. We can again perform the lab, and packet flow is going to be exactly same. I want you to understand the packet flow means information inside the packet. Then TFTP will use TFTP will perform the lab of TFTP while updating the iOS on the router. For FTP we have already performed the lab. For SSH will perform one lab. For Telnet will perform one lab in next class. For HTTP, HTTPS we have already covered. These are the application layer protocols only which we need to understand. We need to check the packet flow, because for an example, if a client machine is not able to access any website, so you can troubleshoot the DNS, that machine is able to resolve domain name or not. You can check TCP connection. Then you can check the port number through Telnet protocol, which like I had shown you in yesterday class as well. That through Telnet how you can check a port number is enabled or not on a particular server. Okay. So see, in OSI model what we have seen, layers, the function of all the layers, and from the transport layer to Ethernet layer we had seen the headers, extra informations with data that will be added by your client machine, and this process is called encapsulation process. But one question is still there, Praphul. Let's suppose one router is there, one router, and this router is connected with one client machine and one server. The MTU size of router is 1500 bytes. MTU size of router is 1500 bytes. And you said based on minimum MTU, your PC client machine is going to decide the segment size. And segment size will be 1500, the minimum MTU, minus 40 bytes. 40 bytes means 20 bytes for 20 bytes for Ethernet header, means if the data size is segment size is 4060, then transport layer header size is going to be 20 bytes, and IP or network layer header size is going to be 20 bytes. So total segment length of data is going to be 1500 bytes. But Praphul, why you didn't add Ethernet header size? PC is going to add Ethernet header as well, and Ethernet header will also have some size. So see what happened on the router. Whenever router is going to receive the traffic on the interface, it will remove L2 header. It will remove L2 header, and whenever it is going to forward the traffic from the interface, on the interface it is going to add L2 header, right? So router is rewriting the layer 2 information, and every device who can rewrite the layer 2 information will always change something in layer 3 header. What will be that change? That change will be decrement in TTL by 1. Which device will change in TTL, decrement in TTL by 1? Whatever devices will rewrite the layer 2 header. It is representing the hops, right? In the IP header, one more field was there, that was TTL, and we had not talked about TTL only in the entire OSI model. So TTL is time to live. It is used to avoid layer 3 loop. It is used to avoid layer 3 loop. How? Let's suppose I have two router 1 and router 2. Bas 10 minute. Router 1 and router 2. By mistake, someone has configured routing here. This interface is F0/0, F0/0. IP address is, let's say, 12.1, and here IP address is 12.2. By mistake, here you have configured one wrong routing. That 10.1.1.0/24 is reachable via F0/0 interface. This is routing table of R1. And on router number 2, 10.1.1.0/24 is reachable on F0/0. Now what will happen if router is going to receive any traffic where destination is 10.1.1.1, any IP address from this subnet? Router will compare destination IP with routing table. It will find the exit interface F0/0 and it will forward the traffic from 0/0 interface. Router 2 will receive. Router 2 will also compare destination with routing table, and in the routing table you can see the route. It will forward traffic from F0/0. Router 1 will be forwarding traffic to router 2. Router 2 will be forwarding traffic to router 1, and your packet will be moving between R1 and R2 because of one small misconfiguration of routing. Here TTL value help to avoid this loop. How? Because every router, whenever router is going to rewrite layer 2 information, it will decrement in TTL by 1. So let's suppose the traffic which is coming on router number 1 with destination IP address 10.1.1.1 is having TTL value 10. TTL value 10. Right? So when router 1 will forward this packet to router number 2, TTL will become 9. When router 2 will forward it to router number 1, TTL will become 8. When again router 1 will forward it to router number 2, it will become 7, 6, 5, 4, 3, 2, 1. Then 0. Once TTL value will become 0 on any router, it will drop the traffic. Means time is expired for this packet. Time to live. This is the time to leave the network. Apart from this, most of the thing we have covered in OSI model, layers, and in the headers, also in the of application layer protocols. Now same lab which I have performed in packet tracer, you can also perform in GNS3 to check the traffic in detail, because in GNS3 you can capture the link through Wireshark and you can see the packet. But Praphul, where is the command? Here is the commands, right? So I am going to share one PDF, right, to get familiar with Cisco iOS operating system, and this PDF includes basic commands on routers and switches. Tomorrow I will talk about this mode as well. Like this is the basic verification mode. Here you cannot apply the configuration. When your router will boot up, you will get access in this mode only. For the configuration, we have configuration mode, and here is the basic configurations. Like to configure host name, here you can get the command. To configure banner on the router, here you can get the command. To save the configuration, here is the command. To enable password on the router, here is the command. To configure secret password, here is the command. There are some verification command. Then to configure password on console port, here is the command. Configure IP address on the router, here is the command. Configure Telnet on the router, here is the command. Enable SSH, here is the command. Enable Telnet on the layer 2 switch, because on the layer 2 switch we will not have IP address. So here we have to create SVI for management interface. Here is the command. To enable DHCP on the router, here is the command. To configure DHCP by using server in packet tracer, here is the process. And somewhere you will also find the relay agent configuration, DNS configuration, right? And after that, static routing. I will talk about static routing later. So from here you can get the basic commands to configure these protocols on Cisco routers, these application layer protocols on Cisco routers, so that you can perform same lab in GNS3. Okay.
Praful, before we finish for the day, last question is, are you going to discuss PTP time protocol as well at some point within the course?
So I talked today as well. I said it is used
No,
to synchronize the time.
yeah, PTP, the precision time control protocol,
No, I am not going
not
to
the
talk about
NTP.
I thought NTP.
PTP. No, not NTP. NTP is usual because the PTP is also a part of the NCore
So
350401
if you want, I can
within
discuss
the.
the basic thing definitely. You can
Yeah.
let me know. Like Praful, please include this topic as
No.
well. Definitely, I will include that.
Yeah, that's probably something I'm personally interested because it's usually used in the low latency trading networks where microsecond based time synchronization is important because then you lose trades, that sort of stuff. Considering this course is a higher level course from CCNA all the way, so I was interested to know. It is a topic within Encore 35401. Hence why I asked. That's all.
Sure, we'll talk about that as well. No problem.
Okay, thank you.
Couple, it's DHCP helper address been discussed or?
We discussed not today DHCP helper address.
Okay.
I've configured DHCP helper address here na, on the router.
Sorry, I missed it. Like, may I know like why it is configured?
It is configured so that router can send DHCP message to the DHCP server. Client is going to generate broadcast message and router cannot forward that broadcast message from one interface to another interface.
Yeah, also because the DHCP server is in another subnet. That is why you configure the. Is that also?
Correct.
That's why you configure the helper.
Absolutely right.
Okay, I'm sorry. Are you here? Do you hear me?
Yes,